Identify the perpendicular bisector and the line segment it bisects. Then explain how the triangles are congruent. Okay, so let's take a look here. First thing I'm going to notice is the congruent segments that are marked. Segment DG is congruent to segment DE, segment GF congruent to segment EF. Okay, now, notice that because of these two congruent segments, segment DG and segment DE, this point D is equidistant, meaning the same distance from E and G. That means point D lies on the perpendicular bisector of segment GE. Now here, let me go ahead and draw segment GE. Okay, now maybe that'll help a little more. So point D is equidistant from G and E, means it lies on the perpendicular bisector of segment GE. Notice that point F is equidistant from G and E also, so it lies on the perpendicular bisector of segment GE. So if both of these points lie on the perpendicular bisector, we can actually draw the perpendicular bisector through these 2 points, because 2 points determine a line. And what I did is I just drew a line DF that really just goes through segment DF. The line DF is the perpendicular bisector of segment GE. Okay, so that's the perpendicular bisector piece, and the whole key is that point D is equidistant from G and E, and point F is equidistant from G and E as well. So now let's take a look at the next part, explaining how the triangles are congruent. So by definition of reflection, point G maps to point E. That means that triangle DGF is congruent to triangle DEF. And that's because of the definition of congruence. And the reason why I can make that conclusion is based on the fact that these triangles are reflections of each other. Since triangle DGF maps to triangle DEF by a reflection, there's a rigid transformation that maps the triangles to each other, and so by definition of congruence, the two triangles are congruent. So just to sum up, we determined that point D and point F lie on the perpendicular bisector of segment GE because they are the same distance from point G and E. So we drew that perpendicular bisector of line DF. We use the definition of reflection to finish the reasoning here.